Okay guys, we're going to go over finding CP of a rocket. A few things, let's go back and review. CP is center of pressure. That means that we're finding the point where surface area is equal on either side. Center of mass is where mass is equal on either side of a point. Stability is what your goal is for this rocket, is to have 1 to 2 inches separating those 2 points, CP and CM, which are natural points of rotation in free space. So, we're going to go real quick over this. I have a rocket, a little bitty rocket. I say little bitty, it's probably about 12 to 14 inches long. But what we're going to do is we're going to trace this rocket. I've already done this. I have traced the rocket. All right, and I have also traced the fins. On this rocket, we're going to have 4 fins, and I've traced it, and I will go and cut all of these out. All right, so I have 4 fins. I'm going to put them on my rocket after I trace them. I take this, I've cut it out, and I have made a 2D model. All right, this 2D model will help me determine where the center of pressure is. Now remember, center of pressure on a 2D model is where we find the center of mass, because that tells us where surface area is equal on either side. So one of the things I like to do after I cut this out, I like to put a crease in it. That helps me to be able to balance this. So I take and I've already done this once, find where this balances. So now I've got this balanced. That is my center of mass. So I will take and mark that on my 2D model. Then I will take my 2D model, come over to my rocket, and I will mark where CP is. Now I've taped my fins and everything on there, so I've got them all on there just so that it helps to determine where mass is. The next thing I will do is I will go and, figure out where center of mass is. Well, on this rocket, center of mass is somewhere right about there where I've got it marked. That's center of mass. Now, if you notice, these 2 points are right here pretty close. It'd be pretty easy for a rocket to spin. I want to move my center of mass this way, to the right, back towards the nose cone. So, if you remember, there's 3 ways to do that. One is to add fins. Well, we've already got 4 fins on here, so that's going to be a little difficult. Move the position of the fins. Well, if I move it up, my center of pressure is going to slide above my center of mass. And if you remember, we always want center of mass ahead of center of pressure. Or we can add mass to the rocket. I have BBs for you to be able to add mass if you so choose to. You'll add mass in the nose cone. You got a little hole right there to put BBs in. It doesn't take a whole lot of BBs. You can move it forward and not put a ton of mass in there. But the thing is, when you put the mass in here, you have to make sure that the BBs do not move. That's your job, is to figure out how to make that happen. All right? So, I can put the BBs in here, adding mass, which will then move my center of mass forward. And I want at least 1 inch between center of pressure and center of mass. Once I get that, I am stable. Make sure that you mark center of pressure and center of mass so that we can identify them. Center of mass has to be in front of center of pressure. So center of mass has to work its way to the nose cone to be stable. I use this 2D model. When you come in to give me your FRR, you must have the 2D model. Like I said, my 2D model, I put 4 fins on there in the approximate location they were going to be at. This is to help me find that center of pressure where surface area is equal on both sides. So, really simple to do, makes a world of difference in your rocket. Look forward to seeing your designs on Friday.